Hello everyone, in this video we shall discuss Move Analytics, that is, how analytics can be applied to distribution and logistics. We shall first define metrics and objectives and then talk about some typical problems. The key performance indicators here are cost and time, such as shipping cost, inventory cost, warehousing cost, and time such as fulfillment time and on-time performance. The objective is to fulfill demand timely and cost efficiently. Typical problems include fulfillment diagnostics, distribution and logistics planning, transportation management, and logistics network design. On large scale, logistics systems are often susceptible to disruptions and may perform poorly or even break down from time to time. Such systems are typically very complex, and thus it is hard to identify the root causes and manage, stabilize, and improve the system performance. Analytics can analyze the fulfillment data in connection to various factors and can quickly identify and pinpoint the most likely causes. As an example, we shall look at one of the largest logistics systems in the world, which fulfills demand for spare parts on ocean liners. Some devices on the ocean liners may fail and thus dysfunction the ship. The spare parts must be delivered to the ship in a timely fashion for repair, or the ship cannot perform its tasks. Demand for most spare parts are small and completely random. This figure shows that 97% of the high priority parts are slow-moving items, with an annual demand of less than 36 units. Thus, the demand is very hard to predict. Because of the significant penalty associated with the device failure, the target service level for the high priority parts is 85% of the demand being fulfilled in one day. For routine parts, the target service level is 85% of the demand being fulfilled in 3 days. Analyzing the data, the histogram of fulfillment time shows that the actual service level is only 17% of demand being fulfilled in one day, 30% in 2 days, and 60% in 1 week, and so on. To achieve an 85% service level, one needs to wait for about 10 weeks. Thus, the actual fulfillment performance is far below the target, a fact that the companies didn't know. One conjecture for the causes of this poor performance is the shortage of inventory. To verify this conjecture, we'll plot out the actual fulfillment time and the total lead time for each SKU on this figure. The total lead time is defined to be the total time it takes for the SKU to be fulfilled, assuming zero inventory anywhere in the system. The red line is the 45-degree line. As we can see that the actual fulfillment time can be longer than the total lead time by a non-negligible probability, around 7%, which implies that even though inventory might be a cause for the underperformance, inventory cannot be the only cause. Something else must also be wrong. So we plot out the histogram again, but for each year from 2008 to 2013. And then we find that in year 2012 and 11, the performance was particularly bad. In fact, they achieved a service level of 85% in 20 days in year 2009, but only a service level of 54% in 20 days in year 2012. Now, linking this observation to the fact that the demand in 2012 is much higher than the demand in other years, so we conjecture that the delays may be caused by the limited capacity of the system to process and transport the demand. Our data analysis confirms the conjecture. There is a high correlation, about 80%, between the number of demanded parts in a week and the average fulfillment time for the demand of that week, implying that a higher demand volume leads to a longer fulfillment time. So the limited capacity of the system is likely the primary cause for the underperformance because of congestion. This example shows the power of data analytics without checking up each step of the system physically, which may take years. Analysis of the performance data can quickly identify the most likely causes. Our second topic is distribution and logistics planning. This is a popular problem in practice. It is hard to balance shipping and inventory costs due to their conflicting requirements. More frequent shipping can reduce inventory but increase shipping cost. Failing to balance shipping and inventory, you may face a high logistic cost together with a poor customer service level. Analytics can help balance the needs of shipping and inventory optimally and achieve the global optimal with reduced cost and improved service levels. As an example, let's look at Verizon Wireless. Before 2011, Verizon used the push strategy to sell phones in the United States. It held about 60% of the phone inventory in the 2,000 plus stores, so customers can buy their favorite phones directly from the store. This strategy resulted in a significant inventory investment, about $2 billion. Given the short life cycle of phones, about 6 months on average, the inventory of cell phones represents a significant risk. In fact, Verizon often have to give phones away for free and suffer a loss. Now, for Verizon, a smartphone costs about $500 and a feature phone about $200 on average. The high inventory risk forced Verizon to consider another strategy, which is the pull strategy, which pulls inventory back from the stores to the DCs, distribution centers, and use the stores only for display and customer experiences. Customers placing orders in stores will receive the phones from the DC by FedEx overnight, free of shipping charges. The questions were, which model is better? By how much? For which products? Clearly, the advantage of push is that customers do not have to wait, and thus a better satisfaction. Also, batch picking and batch regular shipping to stores save warehousing and shipping costs. The disadvantage are significant inventory investment and the risk of obsolescence. For the pull strategy, the opposite is true. Pull enjoys the advantage of a significant inventory reduction and faster introduction of new phones, but suffer a lower customer satisfaction because they have to wait, and a higher warehousing and shipping cost due to unit picking and unit expedited shipping to individual customers. So, the trade-off is between shipping, picking, customer satisfaction, and inventory and the speed of new product introduction. The best strategy is actually product dependent. Let's develop some intuitions first. If we group the products into 4 categories, we can see that for high volume but inexpensive phones, the push strategy may work better because its inventory cost is lower but shipping cost is high. For the opposite category, that is the lower volume but expensive phones, the pull strategy may be better because of higher inventory cost but lower shipping cost. However, for the other 2 categories, such as the high volume, expensive phones, and low volume and inexpensive phones, it is hard to determine which strategy is better without a quantitative supply chain analysis. Applying supply chain analytics, we can quantify for the combination of each product and each store which strategy is better and by how much. Here is an example. For this particular store, the pull strategy generates quite different percentage savings for different types of phones. For the lower volume and expensive phones, it saves 77% of the cost relative to the push strategy. The cost saving is 52% for lower volume, inexpensive phones, and 48% for the high volume and expensive phones. But the pull strategy actually costs 22% more than the push strategy for the high volume and inexpensive phones. So the pull strategy is not always better than push, confirming our intuition. In general, the pull strategy generates net savings for phones with a higher volume and a lower cost. Aggregating the costs of all products into the total cost for this store, we find that the pull strategy increases the picking and shipping costs, but significantly reduces the inventory costs. The net outcome is that if we switch from push to pull, we can save 32% of the total cost, which is about $29,000 per week for this store. Guided by supply chain analytics, Verizon made the transition from push to pull in year 2011. Inventory investment dropped from $2 billion to $1 billion. Soon after, other U.S. wireless carriers followed suit. Verizon stayed as one of the market leaders today. To summarize, supply chain analytics can contribute to distribution logistics significantly. The Accenture High Performance Supply Chain Survey in 2009 showed that the fulfillment leaders can achieve 13% higher on-time delivery, significantly lower shipping cost, and 50% lower finished goods inventory.